In this video, I'm going to investigate the convergence slash divergence of a few sequences. So let's start off with the first one. What is the nth term of this sequence? Sine n over n. So for A, we have sine n, sine of n over n. That's the nth term, right? So A sub n is equal to this. We want to find out what is limit n approaches infinity A sub n, which is going to be just basically limit n approaches infinity sine of n over n. Now, look, as n goes to infinity, sine of n is bounded by basically -1 and +1. As you know, -1 is less than equal to sine of n, doesn't matter what the value of n is less than equal to 1. So this is bounded below and bounded above. So the numerator is not going to be the problem. Okay. However, the denominator, it is going towards infinity. So as a result, the ratio sine n over n approaches 0. As n gets bigger, sine n over n gets smaller and smaller and smaller. It may fluctuate a little bit, remember. Sine could be positive and negative, but it doesn't matter really. So think of it this way. If this is your 0, a sequence could be approaching 0 from right, from left, or from both sides technically if it's jumping back and forth. So at one point it could be here, at another point it could be here. The next point, as n increases, what's going to happen? It could be there or it could be there, getting closer and closer to 0. And ultimately the limit is 0. So this one converges. Now let's go ahead and talk about the next one, which is tangent inverse of n. So B is tangent inverse of n. So I'm going to put A sub n, which is going to be equal to tangent inverse of n. And I'm going to take the limit of it. Limit n approaches infinity. What happens to the nth term, A sub n? What value does it approach? Similarly, take the limit n approaches infinity. Now, as n approaches infinity, the argument of tangent inverse approaches infinity. So in the limiting case, what it is going to be is going to be tangent inverse of infinity, right? But you know, tangent inverse of infinity is pi over 2. So the limit n approaches infinity, A of A sub n is going to be nothing but pi over 2. The next one is n sine of 1 over n. That's the sequence. N goes from 1 to infinity. So the nth term here is going to be an is equal to n sine of 1 over n. So I would like to find the limit of this as n approaches infinity. Okay, so limit n approaches infinity. What happens to this? This could be, so in this problem, so you kind of have to rearrange the terms. As it is, it kind of doesn't tell you much. As n goes to infinity, of course, n is going to go to infinity, then 1 over n is going to go to 0. So n sine of 1 over n, so here n goes to infinity, but sine of 1 over n goes to 0. So what happens? How does it behave in the limiting case? So you kind of have to rearrange the terms as I just mentioned. So it's going to be limit n approaches infinity, sine of 1 over n, and this n I could rewrite it as 1 over n. Now this should look familiar to you. This is kind of like similar to limit x approaches 0 sine x over x, which is 1, as you know, right? So let me write it out here just to refresh your memory. Limit x approaches 0 sine of x over x is equal to 1. And how do we find it? Because we can use the L'Hopital's rule, right? So this is going to be just 1. L'Hopital's rule is just basically taking the derivative of the numerator and the derivative of the denominator if you have a situation such as 0 over 0 or infinity over infinity, one of those extreme cases. So this is actually gonna be 1. So C converges to 1 as n goes to infinity. Now let's talk about D, which is this one, n cosine of 1 over n minus n. So how does this sequence behave as n goes towards infinity? Again, we are going to take the limit n approaches infinity, a sub n, and limit n approaches infinity, this whole thing, by the way. Now, this one is also a special case. You will see, you just have to kind of rearrange the terms and then you will see what's happening here. Limit n approaches infinity, I could factor out the n, right? If I factor out the n, I'm going to have cosine of 1 over n minus 1, right? That I could further simplify to limit n approaches infinity, cosine of 1 over n minus 1, all of it divided by n, I could rewrite it as 1 over n. Now, this should look familiar to you. This is this one, technically, limit x approaches 0, cosine of x minus 1 divided by x. Now, here as n goes to infinity, by the way, what happens? 1 over n approaches 0 and 1 over n approaches 0, cosine of 0 is 1. So you have a situation 1 minus 1, which is approaching 0, right? Divided by 0. So you have a 0 over 0 situation. Now you can simplify it and the answer is going to be just 0, okay? Using the L'Hopital's rule and everything, you probably already know this limit is nothing but 0. So this one converges to 0. So this is going to be 0. Now the last one is E, sine of pi over n divided by sine of 2 over n as n goes from 1 to infinity. So the nth term here is this. So this. So we would like to find the limit n approaches infinity, a sub n is going to be equal to limit n approaches infinity. Now this one is not so straightforward. However, if you kind of play around with the numerator and the denominator, you could convert it into something that looks kind of familiar. So what I'm going to do, I'm going to write it here. So limit n approaches infinity. So let's put it inside a big square bracket. It's going to be, I'm going to write sine of pi over n divided by pi over n, okay? And since I divided by pi over n, I want to multiply it by pi over n. So that's just the numerator. Times the denominator, which is going to be 1 over sine of 2 over n, right? Now I'm going to divide it by 2 over n. And as you can see, why am I doing this? So that I could have an expression that is sine of x over x type expression. So since I divided by 2 over n, I have to multiply it by 2 over n and close the square bracket. And then limit n approaches infinity, right? Now these two terms, I could kind of combine this one and this one. If I simplify it, it's going to be pi over n times n over 2, okay? And the terms inside, so it's going to be times sine of pi over n divided by pi over n, right? Times 1 over sine of 2 over n divided by 2 over n. Now, you know the limits formulas. So limit of a quotient is equal to limit of the numerator divided by the limit of the denominator. So we could go ahead and use that. So I'm not going to write out everything, but as you can see, so let me bring it down here. So this n and n cancels out, right? So limit n approaches infinity times pi over 2. Pi over 2 times sine of x, pi over n, right? Sine of pi over n divided by pi over n, which is like sine of x over x as limit goes to infinity. So let me just go ahead and do a little bit of change here just to save space. Okay, I'm gonna just simplify things here. So this one is gonna go to 1, by the way, sine of x over x type expression as n goes to infinity. So will this. So you're gonna have 1 times 1 over 1, right? So that goes away. So ultimately the limit of this thing is gonna be pi over 2. And that should be your limit for the very last sequence. I hope that this discussion was helpful. Thank you very much.